Hey guys, welcome to some problem that we're gonna solve. And what is this problem and how we're gonna solve it? We'll discuss about two approaches. Basically, what is the brute force approach first, and what is the optimal approach, and then we'll code along. Okay, so let's start with this. So given an array of integer nums, so you are having a array of integer nums and an integer target, and you have to return indices of two numbers. Basically just two numbers you have to return, not more than that, that add up to the target. So basically the nums, let's say nums, okay, of I and some more plus nums of, let's say, I plus 2 might be equal to target in our case. So I have to return I and I plus 2. This might be an answer. So okay, this might be an answer. Okay, problem statement is clear, pretty much simple. Brute force, what will be the brute force for this? Basically one of the best solution that you can have is, basically, let's just look at by example wise. So you have 3 2 4. Okay, now I'll keep one pointer over here, and I will try to see what are all the possible values that are added to this value that achieves me a value of 6. As soon as I get the value of 6, I'll exit that. Okay, now let's just start one by one. So I'm having one value as a 3, okay, currently, and then I go to this 2 and I say 3 plus 2, does it equal to 6? No, it doesn't equal to 6. So what I do is, okay, nothing, no issues, I'll go to the next number. Does 3 plus 4 equal to 6? Oh, it's still not equal to 6. Okay, no issues, nothing bad. I'll just move my pointers ahead. Okay, now I'll put my pointer 2, and the next pointer I'll put over here. So next question will be, does 2 plus 4 equals to 6? You will say yes, 2 plus 4 equals to 6. That means you are having your answers, you exit your loop. Okay, so how would it look like in a code? It's a repetition, just the same thing that we discussed. What it will be looking like? Okay, let's say you will be having something like, I'll say the first loop will be for, and something like int I equal to 0, right, and I less than, let's say this is the size, and I plus plus. Okay, and in this you will say, okay, in this I'll say, okay, for int let's say j equal to, it's always going to be I plus 1, right, and j also needs to be less than n, right, and j plus plus, right, and then inside this loop, let's change the pen color. So inside this you're gonna have something like, okay, I have this, so I'll say if you know nums of I, right, if plus nums of j double equals to target, then you basically return the indices. Basically you return those indices, and if not, you will return something. There will always be an answer, so you don't have to worry about that. You can return the answer in any order, and you may assume each input would have exactly one solution, so it's gonna be there, but still in the end you can return -1, just so that your code doesn't break. Okay, so that is a very naive approach, and this is like taking your o n square of time, basically. So you see, this is taking o n square time, because if the input parameters were big, let's say instead of this I append more parameters. Let's say I added 5 here, I added 6 here. Okay, I added more. Okay, now let me clear this for a moment. Why I'm saying this is a very bad in this situation, because the constraint of this problem are very huge, like 10 to the power -9, and even the size of these arrays are 10 to the power -9. So that's a very huge number. Okay, so let's say I had a target of 11, let's say I wanted a number as a target. My target in this array was 11. Okay, so what will be the case in this scenario? You'll put your pointer over here, first pointer, and then you'll be, let's say, let's change the color for the second pointer, let it be white here. Okay, once you will see, hey, does 3 plus 2 equals to 11? No, it's not. Then you will move your pointer ahead. Then 3 plus 4, does it equals to 11? You say no. 3 plus 5, no. 3 plus 6 is still not equal to 11. Okay, now it's time for me to move my pointers ahead again, right? So you'll put your outer pointer over here. Okay, and then you will say, okay, 2 plus 4, does it equals to 11? You say no. 2 plus 5, 2 plus 6, again no. Okay, and then again the same pain will be there for 4. Okay, you'll say 4 plus 5, does it equals to no, and 4 plus 6, does it equals to no. Okay, so then you come to 5, then you will say, hey, does 5 plus 6 equals to 11? Oh yes, it's equal to 11. Oh my, I got the answer. Unnecessary traversal for this whole, for this 3, then this for 2, then this for 5. And just imagine 10 to the power minus 9, that's a huge number. Okay, you will get a TLE. Okay, in these cases, if you are having ON square solution. Okay, so better to think of an approach that can help us in this section. Okay, so let's think about a section and work on it. So
now let's start with another fresh example. Maybe this time let's say 3 2 7 4 5. Okay, what I will do is I have a complement formula that over c t minus arr of 5. Okay, now what I'm saying is let's have a hash map. Okay, and I'll store some values in hash map, basically values of these. Okay, because this is not sorted, and the value is like 10 to the power minus 9 to 10 to the power minus 9 plus 9, the minus 10 to plus 10 power 9. So that's huge. So let's use unordered map basically here. Just bear with me. So when you go to 3, you say, hey, do I have a complement in my hash map? No, I don't have a complement in my hash map. So what I will do it, I will store 3 basically. That's it. I'll just store 3 and return x in this. Okay, no issues. Now you go to 2 and you say, hey, do this complement 2. So target is here. Okay, as 6. So do I have a any complement 6 minus 2? Do I have a 4 in this? You will say no, you don't have a 4 here. Okay, then it's simple. Let me add 2 with its index 1. Then you go to 7. Okay, and with 7 you do this maths. Okay, 7 my 6 minus 7 basically, and they say minus 1. Oh, then you say minus 1. Do I have a in this hash map? No, you don't have anything in that hash map. So you say, okay, let me just put 7 over here and this index. Okay, then you go to this 4. Now you do 6 minus 4, you get 2. Okay, so what will happen is that will become 6, right? Minus 4, 2, and 2 is already there, so it's a match, and here you go, you got the answer. Yeah, and the complement exists, so you return this and you return current index of this and you get the answer. So for more we'll code it more. Okay, so time to solve the problem. Okay, so we have a basic template of the C++ code. We'll solve it through the optimal approach that we discussed basically. So first of all, let us declare a map in a C++ language. An ordered map basically we want to declare, because the lookup complexity is O of 1 in this case. Okay, if you're a beginner, don't go much into the detail, just keep in mind that hey, it's O of 1. Okay, in worst case it's O(n) square, but if we get a TLE, then we will move to the ordered one. Okay, so let's see if we get a TLE or not in that case. Okay, so I have declared my unordered map of type int and int.
So basically this will be storing the value of the arrays, and this will be storing your indices of that value. Okay. The thing that I was saying, like, is beside an ordered map, you might be thinking you can use an why to use an ordered map. You can use an empty array and set the bool flag to 0 or 1. That is one another approach, but those approaches fail because you have having such a huge value that it might not be like good idea, because this value is too high. And this size of array won't be supported if you are making a bool array basically for this solution. Okay, so max you can go is 10 to the power 6 and 10 to the power 7, maybe if you declare it in global. That's not a good solution. Then in that case you will definitely run in the stack overflow. Okay, so in 10, let's say this will be the size, so nums dot size. Okay, and let's say for int I equal to 0 while we traverse this. Okay, I plus plus, let's say main magic happens over here, complement the, let us short it out, let's say comp. Okay, and I'll say target minus nums of I in our case. Okay, so that will be a complement, and what we want to do is we want to look up for that complement, if that complement exists in our unordered map or not. If it exists, then hey, there we go. Both the formula basically, like complement is equal to target minus nums. So basically, hey, there you go. You have that number, other number, and the current number. So these two, complement and nums, makes the answer basically, right? So there you go. You will have that answer. Now, if map dot, basically this tells you whether, like, we'll just say if we have its count, if it's not equal to 0 basically, then we'll go inside this if block. Okay, and we'll just simply return the two indices. Okay, so that will be our map, whatever your comp value will be, this, and whatever your current this index value is. Okay, now if what if we don't find, see, let's say 3 6 minus 3, you say you get a 3, complement doesn't exist, but in future use case it might be a possibility that it might be used, right? So you also need to keep storing those values, right? So map equals to, basically for a image, like for this key, say for 3, I'll store its index also along with it for the lookup. Okay, and then we'll have a basic return which we might not be using, but since it's a vector int, so we add this as a return type. Okay, it must return if it doesn't go inside this. Okay, let's test it out. I have a custom code. Okay, forgot to add that. Okay, yeah, all this is pass. Let's submit it. If we get a TLE, then we'll make it ordered. But okay, yeah, it's all submitted, it's all accepted, we are good. Okay,